Hello, my name is Simranjit Singh, and today we will start with the DBMS topic, transactions. Transaction is DBMS is one of the most important topic that you will find, and it deals with the fact that our transaction processing system works on the concept that will be covered in this video and in the upcoming videos. Okay, so simply if you see what exactly is a transaction, so transaction can be referred to as a transaction is a collection. Just I'm writing so that it may be more clear. So transaction is a collection of operations that forms a single unit of work. Okay, so what is the meaning of it? I'm going to explain it. That forms a single unit of work. Now what is the meaning of that and what is a single unit of work? Okay, so suppose that you are in a bank transaction system. Suppose this is a bank database system. Okay, so in this bank database system there is a transaction T1 that we are going to perform. Okay, so what this transaction is actually doing, it is taking there is two accounts, A and B. uh, in A account there are 100 rupees, in B account there is 200 rupees. Okay, so now what I'm doing is that I'm transferring 50 rupees from A to B. Okay, so what will be the amount after this transaction? So after that, A will be reduced to 50 and 200 will be changed to 250 because we are transferring 50 rupees to a B account. Okay, so how do you write this particular operation? So it is written in a DBMS. It's like you read the value of A, you deduct the value of A, you write the value of A, you update the value of it to be 50, and then you again read the value of B and you again update the value of B, that is you're adding 50 rupees because 50 rupees is deducted, and then you write the value of B. Okay, so this is referred to as a single unit of work, one single logical unit of work. Okay, so in this work what is happening, that you are taking 50 rupees and you're giving it to another account. Okay, so in the transaction, reading means you are taking the value of A to be 100, you're reading the value of A to be 100 from the from the hard disk memory, you can say it, from the secondary memory to your main memory, and you're changing the value of your, this is, suppose this is in a secondary memory. When you read the value of A, you take this value into main memory, that is your RAM. You read the value of A to be 100, you update the value of 100 to be 50, and you again write the value of A to 50. Okay, so this is referred to as one single the whole set of operations is referred to as one single logical unit of work. Okay, so I'm just telling the meaning of what is read of A and what is write of B. Okay, so it involves that when you are reading the value of A, you are taking the value that is stored in the secondary memory and you take that value into your main memory, and then you are making some operations, and then you are again writing the value to the secondary memory. Okay, so this is a very basic understanding that how you perceive a transaction. Okay, so it is not like that there is only one transaction that happens in a bank database management system. There can be multiple transactions. Okay, so there can be 1, 2, 3, 4 millions and millions of transactions that happens every second. Okay, so basically the transaction can be divided into two parts. Okay, so first part is referred to as that deals with input output operations, and the second part where CPU operations are needed. Okay, so it is very close to what you have studied in operating system, where again we have seen that there is a concept that uh, many processes only need input output operations and many processes need CPU operation. Okay, so those processes which are not taking any IO memory. Suppose I'll give you an example. What do I mean by this? So if in order to maximize what you say, in order to maximize the efficiency of a system, suppose some P1 process is using an IO operation. So rather than waiting for there will be another processes. So rather than waiting for P1 to complete the IO, so I will try to find that particular process that only needs CPU operation. Suppose P3 needs only CPU operation. So I will P1 is now using IO operations and P3 is now going towards the CPU operation part. So that will be a win-win for me, because at the same time two processes P1 and P3 are running. Okay, so this is what do I mean by when I say the transactions are of they can be divided into two parts. First one is IO transaction and second one is your CPU operation. It means that some particular transaction only need IO operations and some transaction needs CPU operation. Like in this particular example, you can see their CPU is needed because there is arithmetic operation going on. Okay, so now if you see here, if I just write the same transaction that we have seen, like read of a equal to a minus 50, write of a, write read of b, and b equal to b plus 50, and w. Okay, so now you have to only identify that which one of these operations are IO and which one of these operations are CP. Okay, so I'll give you just a little 5-10 seconds. Okay, so just pause the video and try to guess which one of this will be IO operations and which one of this will be CPU operation, and I'll tell you after 10 seconds. Okay, just pause the video and try to do it. Okay, so returning to that, if you're seeing here, this is a read operation. So you are taking you're dealing with here input output operation. Okay, so reading means that you're taking the value from the secondary memory. It means it is part of input output operation. Here some arithmetic calculation is going on. You can directly say therefore that CPU is needed. Here it is again IO operation because reading and writing is a part of IO operations. This is again IO operation, this is a CPU operation, and this is again IO operation. Okay, so if you're seeing here, most of the operation in this particular part is IO operation. Okay, so it means that uh, CPU may sit idle for most of the time because there is no need for CPU. Okay, so CPU is only needed 2 times, but IO is needed. You can say IO is needed 1, 2, 3, 4 times. Okay, so if I just write that transaction, how in order of their usage, how will the transaction T1 looks like? Okay, so transaction, this is transaction T1, and it will look like it is needing IO, then it is needing CPU, and then it is again needing IO, and then it is again needing IO, and then it is again then it is needing CPU, and then it is needing IO. Okay, so in order to increase the efficiency of the system, so I want to write execute another transaction, that is transaction T2, in such a way that when the transaction T1 is using a CPU IO, it is using CPU, and whenever the transaction uses CPU, it is using IO. Okay, so if I does that, you're seeing here now the CPU is not sitting idle, as well as the IO operation part is also not sitting idle. So this is referred to as 100% usage of IO as well as CPU. Okay, so this system is referred to as the most efficient system that you can find, but again this is completely, I can say, hypothetical. You will not find another transition that exactly uh, sit like this. Okay, but I'm just giving you an example that if you're able to find the transaction, that the utilization of this particular thing will be to 100%. Okay, So CPU utilization as well IO operation utilization, you can say it reaches towards 100%, and that is very very high. Okay, so now it means that you have to perform two particular transaction at once. Okay, so if T1 and T2 are executed at the same time, only then you will be able to achieve this kind of utilization of the system. Okay, so if you're doing this is referred to as concurrent processes. Okay, so it means that the transaction T1 and transaction T2 are executed at the same time, so this is referred to as concurrent transactions. Okay, so if there are concurrent transactions that are going on, then we definitely need something called a concurrency control. Okay, so we definitely need something called a concurrency control. Now, what is the meaning of concurrency control and why we need it? I'll tell you about this, but understand this, that when there are more than two, when there are more than one transaction going on at the same time, it is referred to as something called a concurrent transaction. Okay, so it may be possible that transaction T2 tries to access the same variable that transaction T1 is working on. Okay, so if this happens, there is a lot more, what do you say, chaos that can be unleashed. Okay, similarly, in the case if you have studied operating system, you may have also seen there is something called a critical section when there are two processes try to access the shared resource. Okay, so this particular kind of problem can also happen there. Similarly, we are using the same concept here. Okay, so when transaction T2 and T1 are using the same shared variable, there can be a lot of things that we have to see. Okay, so simply I'll just give you an example before starting it out. Suppose there are two transactions and they are concurrent, T1 and T2. Okay, so suppose T1 is again the example is very similar. You deduct 50 rupees, and now the transaction T2 read the value of A, because we have not written the value of A, so it will read the value of A to be whatever the starting value. So I'll give you an example. Suppose it's deducted the value to be 25. Now it writes the value of A, and now it writes the value of A. Now what exactly will happen here? Okay, so suppose you are started with the value of A to be 100. Okay, so now it reads the value of A to be 100, taken it into the memory, main memory part, and then what happens here is that you just deduct the value of A to be 50. Okay, so when you deduct the value of A to be 50, so the value of A here is 50, but if you're seeing here, you have not transferred the value to the secondary memory. Okay, so if you haven't updated the value in the secondary memory, read of A, it will again read the value of A to be 100, not 50. It will again read the value of A to be 100, and when it deduct it and it deducted by 25, it is 75. Now it writes the value of A to be permanent change here, that will be 50. So now the mean value that has started with it changed to 50. Now when it writes the value of when it writes the value of A, it changes the value to 75. Okay, but actually that should not happen. Why? Because you what is happening in this two transaction? Yeah, you started, a person A has 100 rupees, it has transferred 50 rupees, and it has again transferred 25 rupees. Now it should, that person A should only be left with 25 rupees, let alone 75 rupees. Okay, so if you're seeing here, when there are two transactions involved, so these are called interleaving of transaction. Okay, so I'm leaving the transaction in between, I'm changing, giving the control to T2. Okay, so when it happens there, when you are interleaving the transactions in between, there may be these kind of problems that can arise. Okay, so it is fairly very common to happen something like this. Okay, so that is why we need something called a concurrency control system. Concurrency control system. Okay, so it is very much needed here. If we are able to have such system in place that can deal with this particular things, only then we can say that we have developed a robust system. Okay, similarly, okay, okay, so now in order to implement this transaction, what you say, concurrency control system, so we have some properties that we assign to each transaction. Okay, so this property is very commonly and very popularly referred to as acid properties. Acid properties. Okay, now what is the meaning of acid property? So every particular word, every particular letter has a meaning. Okay, so here A means atomicity, C means consistency, I means isolation, and D means durability. So guys, transaction should have, or a transaction management system should have these properties such that we are able to implement the concurrency control system effectively. So we need this particular thing. Okay, so now what is the meaning of each of this property? I'll go through it one by one. Suppose I'm talking about atomicity. Okay, so everything is in the name, so it just says all or nothing. Okay, so either the transaction completes with commit operation. If there is any failure before the commit operation, everything will be rolled back. Everything will be rolled back. Okay, so it just simply says that if the transaction is completed, then it will be completed and the values are updated to the secondary memory as well. Okay, so if there is any failure before it, you have to roll back all the values. So this is referred to as all or nothing approach. Okay, so it is managed by something called a transaction manager. Okay, so this is the name of the software that is being used to do this. Okay, it's a software that does this atomicity property part. Okay, another is consistency. Okay, so consistency, it's in simple meaning, it means that it should be correct. Okay, so it talk about the correctness uh, of the operations. Okay, so what do I mean by this? So this is again what you say. Suppose A is, the value of A is 100 and the value of B is 200. Okay, so what happens here is that when you transfer the value, after transfer, suppose you are transferring 50 rupees, and after transferring the value, change the value will be changed as, the value of A will be 50 and the value of B to be 250. Okay, so now if you total the value, what is total value? Here if you total the whole amount, it will be 300. Again, if you total the whole amount here, it is 300. Okay, so it should not like that these 50 rupees should be lost in the system. Okay, so if you are transferring some money, then the total sum should be same. Okay, so just this is referred to as consistency. Okay, so it should not happen like that. If you're transferring 50 rupees, this 50 rupees is gone. Okay, so it has to be transferred to another person, and the total sum of the whole transaction should be the same as it was before. Okay, so this is referred to as consistency of the transactional state. Okay, so now this particular thing is managed by application or user programmer. So this is the responsibility. So I'm just writing the responsibility. that who is responsible for which particular property. Okay, so the third one is your isolation. So it is again in the name. Now isolation means that each transaction must be executed without knowing that what is happening with other transaction. Okay, so what it means is that transaction T1, there are, suppose there are 4 transactions that are executed at the same time, but transaction T1 will think only I am executing at this time. Similarly, transaction T2 will think only I am executing at this time, and transaction T3 will also think the same. Okay, so they are not aware of each other. So this is very, very much needed here, that they should not be aware that other transactions are working in parallel. Okay, so this is maintained by again a software that is referred to as concurrency control manager. Now the fourth one is referred to as your durability. Okay, so durability, it's again in the name. All the updates, all updates done by a transaction should be permanent. All updates done by the transaction should persist or should be permanent. Okay, so it means that if you have change, you have transferred like 50 rupees, you have 200 rupees, you transferred 50 rupees to your friend, it should not be like that. If the transaction is failed, your friend will also get 50 rupees and your amount is not deducted. So it should not happen something like that. If there is any kind of a failure in the transaction, either the whole system should be rolled back. But if a commit operation has been placed there is no way that your transaction should be changed. Okay, so if there is any update or change that is made in the DBMS state, that particular change should persist. Okay, so this particular thing is managed by something called a recovery manager. Okay, why recovery manager? Because most of the time there are failures that can happen due to power outages and due to many other reasons. Okay, so if this happens, that recovery manager becomes active and it makes sure that all the updates that has being made should be again processed. Okay, so it does not, it is not like that if you had transferred 50 rupees, you check after one day, your balance will be the same. So this does not happen. Either if there is a, if there is any kind of outage happen in the system, this never happens, because this is a responsibility of a recovery manager. Okay, similarly, uh, now we are going with what are the main stages or states of a transaction. Okay, what are the states of the transaction, how many states the transaction may go through, this will we will study. Okay, so firstly, the transaction can be active, it is active, well and alive, going. Now either two things happen: rather the transaction is failed. If it is failed, then the transaction will be completely aborted, all the values will be rolled back, all the updates will be rolled back as well. But another operation will be something called partially commit. Okay, partially commit means that we have made changes in our main memory. Now the next step will be that we make changes to the secondary memory. Okay, so that will be your full commit operation. Okay, but it can also happen that when you are partially committed, means that the changes that you have made is only in your RAM. Okay, so if it is in your RAM, if there is a power outage or if there is any kind of a failure, then the transaction can also fail. Okay, because it is not actually written to the secondary memory, so there might be a chance that your transaction can fail. Okay, so everything before commit. Okay, suppose you have read the value of a, deducted 50 rupees, and you have written the value of a, but you haven't put commit here. Okay, so here what happens here, you read the value of A, you deducted the value of 50, you return the value of B, and you put commit operation. When you write commit operation here, it means now the changes will persist. Okay, but because your again your scope is still here only, that you have not written commit, you're only in the main memory. Okay, so your changes had not been transferred to the secondary memory, that is why it is partially commit. So at this stage this can be possible that there is some kind of a failure that can happen. That is why there is an arrow from partially commit to failed. Okay, so this can happen. Okay. Okay, now moving on forward, now I'll just will try to explore what are the problems that can occur with the concurrent execution. Okay, so what are the problems that can occur when you're doing a concurrent execution? Okay, I'm just writing like problem with concurrent execution, because we already know we are doing there may be the same variable that two or three transaction want to access. Okay, so if this happens, there might be a very good possibility that there may be many problems that can arise from it. Okay. Okay, so now so again we are taking a scenario here. Suppose we are transferring 50 rupees A to B. This will be our transaction first. Another, suppose we are taking 4%, adding 4% interest to the account of A. Okay, so this will be transaction T. Okay, so now see here, read the value of A, deduct 50 rupees, change interleave, because it's a because it is a concurrent transaction, so interleaving can happen. So read the value of A, 4%, whatever is the 4%, I'm giving interest. Write the value of A, read the value of B. So I also have to add 50 rupees. Okay, I'll just make it a more clear. Two transactions. Okay, now what is happening here? Okay, so suppose I'm starting with the value of A to be 100 here, again 100, so it is deducted to 50 rupees. It has taken the value of to be 100, and then it is adding 4 rupees, so it will be 100 100 of 4 here, and here we are writing the value of A to be 50. It is what do you say, rewritten by 104, and again whatever is the transfer. So this is not that much important, but see here what is happening here is that you started with 100, you have 50 rupees out of it, and that value is changed to 104. But actually what should have happened here, you should have gotten the interest on 50 rupees, but you're getting the interest of on 100 rupees. Okay, so why it is happening here, that you have lost the update that is being posted by the transaction P1 here, T1. Okay, so see here, when you return the value of 50, it is rewritten by the transaction T2, that is 104. Okay, why this happened? Because there is first, when you write the transaction, another transaction is writing in the next step. Okay, so if this happens, this is referred to as something called a write-write conflict or lost update problem. Okay, So what is happening here, that you have taken the value of W to change to 50, and it is again rewritten or changed by the transaction T2 to 104. Okay, so this particular update is not persisting. Okay, so it is just quickly updated by another transaction. Okay, so when a rewrite write operation are there in a quick succession, this is referred to as write conflict. Okay, so we always avoid that. Okay, so if there are two writes on the same data item, okay, so here the data item, this is referred to as data item, A is the data item. Okay, so if there are two writes on the same data item without any read operation, okay, because there is no read operation by transaction T2, it's already done. Okay, so if there are only two write operations without any read operations, so this particular conflict will occur. We always try to avoid it. Okay, so if this should not have happened, if I just made this transaction without, if you're blindly writing the value here, just read the value of A. So I might have gotten that the value of A has been changed. Okay, so these are the problems that we can get. So first one is your write conflict. Okay, so another one is your second problem. Again, I'll give you a scenario here. Suppose there are two transactions, T1, T2. Read the value of A equal to A minus 50. Write the value of A. Okay, so again I'm reading the value of A. What I'm doing is taking 4% of A and adding 4% A plus X. Okay, so it will be W of A. Similarly, write the value, read the value of B, adding something B plus 50 that I have to do, and write, and then there is a commit operation. Okay, so what happened here? Okay, so again take the value whatever you want. So I'm just starting the value of A to be 100. Here it is updated to 50, and suppose commit is already being done. In this case, when we have updated the value of A to be 50, now it reads the value of A to be 50. Okay, so this is changed here. Okay, so now it is 4% of 50. I think it is 2, so it will be 52. I have written the value of A to 50. Suppose when I am writing write of A here, just suppose that we are writing the value to the mean secondary memory, in this case only. Okay, so I am again writing the value to be 52. Okay, so what happened here, I've started A with 100, change the value to 50, and change the value to 52. Okay, suppose at this particular stage this particular transaction failed. If this particular transaction failed, it is all or nothing. So atomicity will come into play. So it will roll back the values, whatever the values here, it will roll it back. Okay, so it means it will change the value of A to again 100. Okay, but if you are seeing here, it should also, the transaction T2 should also be rolled back, but it does not happen. Why it does not happen here? Because this transaction is not failed. Okay, so only T1 transaction is failed. So it is some, just see here, because T2 is reading from uncommitted data. Okay, because the commit is here, T2 is reading from the uncommitted data. That is why this kind of scenario happens. Okay, so suppose in an examination hall there are two persons, T1 and T2. Okay, so what happened here is that T2 is copying everything from T1. Okay, so T1 is writing everything, each and everything, and after some time T2 is thinking, I've copied enough, I think I am done, I will easily be able to get passing marks, and I'm fine with it. Okay, so what does T2 does, it goes to the invigilator and it submits the paper. Okay, so when it submits the paper, T1 thinks that what I have written in the paper is actually everything is wrong. So it got the new sheet and just tries to write from the starting. Okay, so this kind of scenario happens here. So because T2 is submitting the sheet before T1, now T2 will be failed. Okay, similarly it means that T2 is not getting the correct value. Similarly here, that T2 here, this is T2, T2 is copying the value from T1, whatever T1 is doing. So now it update the value to 50 and it is taking the value to 50. Okay, but when the rollback happens, T2 is not there. So T2 commits and it updates the value, and it now it will be permanent to the value of A is permanent to 52, but it is now rolled back to 100. Okay, so this is referred to as write read conflict. Okay, write read conflict. Okay, so whenever you have written the value and that is being immediately read by another transaction, and the whole transaction is not committed yet. Okay, so this is referred to as write read conflict, and it is also referred to as dirty read problem. Dirty read problem. Again, this is very prevalent. Okay, now the third problem. T1, T2, you have read the value of A. Suppose again it is read by another transaction. Change the value. Suppose you have deducted 15,000 rupees and you have written the value of A, something like this. And again you have read the value of A and you have deducted this much rupees and you have written the value of A. Okay, so because you see here, suppose I have started with the 20,000 rupees, it again read the value to 20,000 and it deduct the value of 20,000 to 5,000. Okay, so now when this particular transaction T1 reads the value, it will be 5,000 here. Okay, so now T1 thinks, because according to T1 it is not aware of T2, T3 or T4 or any other transaction that is being there. Okay, so it's again breaking some kind of a rule here of isolation, if you're seeing here. Okay, so it says that I have not do any kind of a modification on this. Okay, so how the value of how the value of A is being changed from 20,000 to 5,000 here. Okay, so this is the problem. Okay, so it means that if transaction T1 has not made any changes, it means that transaction T2 or there is any other transaction that has made the changes, but T1 is not aware of that because of the isolation property. Okay, so that is why this problems happen, and this is referred to as your read write conflict. Okay, read write conflict. So this is also referred to as unrepeatable read problem or non-repeatable read problem. Okay, so only problem is that uh, only problem is that T1 should think that I have not made these changes. So who made it? Or because it is because of the isolation property, T1 is not aware of any other transaction, so it may think that there is some problem in the database that it is changing on its own. So that may be a problem here. So that we do not never want. Okay. So this is referred to as your main problems that we face during when we try to do concurrency, when we try to execute concurrent transactions. Okay, these are the main problems that we face. Okay, so now I'll just start with it that I'll try to do now a schedule so that we will be familiar with all the schedules that are being available and how and what are these schedules. Okay, so I'll discuss the schedules in the next one. Okay, so see you in the next one. Thank you for listening and see you in the next one. Okay.